Students, will continue the next question in the same section. Show that f of x is equal to 5x minus 4, 0 less than x less than or equal to 1, 4x cubed minus 3x, 1 less than x less than 2 is continuous at x is equal to 1. The question itself explains that you have to show that it is continuous. So, continuous means left limit, right limit and the value of the function will be equal. So, value of the function at x is equal to 1. I have written it already, f of 1. You will take first function or the second function. Yes, you will take the first function because it is at x is equal to 1, it is equal to 5x minus 4. That is 5 into 1 minus 4, 5 minus 4 is equal to 1. Then limit of x tending to 1 plus, that means right hand limit. You take the right hand limit and the left hand limit and you can show that it is equal to 1. So, these two cases are applicable. Next one, you copy down or you will take down the questions. You can work it at O, take the point and you will get the answer. Next one, on finding the values of a constant, value or values, sometimes it can be values of a constant given in the definition of a function when it is continuous at an indicated point. On finding the values or value of a constant. So, here you see in this question the constant is equal to lambda. In the definition, when it is continuous at an indicated point. Already it is given that it is continuous at an indicated point. Continuous means left limit, right limit, value of the function is equal to the same. Now, let us see. At the point, you have to check minus 1. So, f of minus 1 is equal to lambda. Not equal to minus 1, it can be left limit or it can be right limit. Limit of x tending to minus 1 minus f of x. So, what did I take? I took the left limit at the point minus 1 is equal to limit of h tending to 0 is equal to 0 minus 1 minus h the whole square minus 2 into 1 minus 1 minus h minus 3 divided by minus 1 minus h plus 1 equal to limit h tending to 0 a minus b the whole square a squared plus b squared plus 2ab minus 2 plus 2h plus 2 plus 2h minus 3 divided by minus h. Isn't it? Yes. That is equal to limit h tending to 0, limit h tending to 0, h squared plus 2h plus 2h 4h plus 1 plus 2 3 minus 3 cancel 0 divided by minus h, or that is limit h tending to 0 h into h squared h plus 4 divided by minus h, cancel. But by the condition, you know that 1 is equal to 2. Why? Because it is continuous at the indicated point. That means minus of h plus 4 is equal to lambda, or minus h minus 4 is equal to lambda, but here it is limit of h tending to 0. So this value becomes 0 minus 4 is equal to lambda, or lambda is equal to minus 4. Lambda is equal to minus 4. This is how you do. Either you take the left limit or you take the right limit. It's up to you. Next one. Determine the value of k. Determine the value of k. This is another type, the same type, second type. Determine the value of k for which the constant, for which the function is continuous at, x is equal to 3. F of x is equal to x squared minus 9 by x minus 3, x not equal to 3, equal to k at x is equal to 3. So what is the question? It is continuous, already given. Now you are asked to find out the value of k at the point x is equal to 3. As I told you, last case we took the left limit. Now we will take the right hand limit. Limit of x tending to 3 plus f of x is equal to limit of h tending to 0, 3 plus h the whole squared minus 9 divided by 3 plus h minus 3, which is limit h tending to 0, 9 plus h squared plus 6h minus 9 divided by h, plus 3 and minus 3 cancel. Here plus 9 and minus 9 cancel, which is limit h tending to 0, h into h plus 6 divided by h. H and h cancel. So limit of h tending to 0 is equal to 6. But what is given at the point f of 3? F of 3 is equal to k. But you know that limit x tending to 3 plus f of x, or limit of x tending to 3 f of x is equal to the value of the function. F of 3 is equal to 6 is equal to k, which means k is equal to 6. So I have discussed two questions, one with the left limit and one with the right limit. Now next one. Find the value of the constant k. Find the value of the constant k so that the function given below is continuous. F of x is equal to 1 minus cos 2x divided by 2x squared, x not equal to 0, k if x is equal to 0. So find the value of the constant k. The function given below is continuous. F of 0 is equal to k. Limit x tending to 0, f of x or 0 plus h, 0 plus is equal to limit of h tending to 0 f of 0 plus h is equal to limit of h tending to 0 f of 0 plus h is h 1 minus cos 2h divided by 2h squared. Limit h tending to 0, 1 minus cos 2h is equal to 2 sin squared h divided by 2h squared. The reason is 1 minus cos 2h is equal to 2 sin squared h. 2 and 2 cancel. This can be written as limit of h tending to 0 sin h by h the whole square, which is equal to 1. From 1 and 2, the value of k is equal to 1. The value of k is equal to 1. Next one. Find the value of a. Find the value of a. Value of a of f of x is equal to 2x minus 1, x is less than 2, a x is equal to 2, x plus 1, x is greater than 2, is continuous at x is equal to 2. Here it is a special case. The constant a is given and it is divided into 3 intervals. X less than 2, x less than 2, the left limit value is 2x minus 1. At x is equal to 2, it is equal to a. Greater than 2, that is the right hand limit, it is equal to x plus 1. So, we will write first f of 2 is equal to a. First one. Limit x tending to 2 minus f of x is equal to limit of h tending to 0, 2 into 2 minus h minus 1. That is limit of h tending to 0, 4 minus h, 4 minus 2h minus 1, and that is equal to h is tending to 0, that is equal to 3. But we know that since it is continuous, limit x tending to 2 minus f of x is equal to f of 2. That is a is equal to 3. A is equal to 3. Either you can take this one or you can take the right hand limit. I will show you right hand limit. Limit x tending to 2 plus f of x is equal to limit h tending to 0. It is equal to 2 plus h plus 1. H is tending to 0. That is equal to 2 plus 1 is equal to 3. By the continuity property, limit h tending to 2 plus f of x is equal to f of 2. That is f of 2 is equal to a, and that is equal to 3. Either you can take a left limit or right limit and get the value for the constant a. Next one. Next one, find the value of A. Find the value of A. Value of A such that f of x is continuous at x is equal to 0. F of x is equal to sine squared ax divided by x squared, x not equal to 0, equal to 1, x is equal to 0. Find the value of A. So, f of 0 is equal to 1. Limit x tending to 0 plus f of x is equal to limit of h tending to 0, f of 0 plus h is equal to, not equal to 0, you have to take this one. Limit h tending to 0, sine squared ah divided by h squared. Sine squared ah. That is equal to limit h tending to 0. I'll rewrite this as sine ah the whole squared by h squared. But you know that limit h tending to 0, sine h by h is equal to 1. Isn't it? Sine h by h is equal to 1. So here I have to make a change. Limit h tending to 0. Here the angle is, it is equal to AH. So what I will do is sine AH by AH the whole squared. So I have divided by A square, multiplied numerator by A square, and that is equal to 1 into A squared equal to A squared. So what have you obtained here? A squared is equal to 1. A squared is equal to 1, or A is equal to plus or minus 1. A is equal to plus or minus 1. Next one. Are you ready? Okay. Now, the last question. Find A and B. Find A and B if f of x is continuous at x is equal to 1. F of x is equal to 3ax plus b, x greater than 1. 11, x is equal to 1. 5ax minus 2b, x is less than 1. Here the difference is you have to find two values a as well as b, given that the function is continuous at a particular point. So x greater than 1, right limit, at the point 11, less than 1, left hand limit is equal to 5ax minus 2b. So we'll start with, since continuous, limit x tending to 1 plus f of x is equal to limit x tending to 1 minus f of x is equal to f of 1. And what is f of 1? F of 1 is equal to 11. Mark that as equation number 1. Limit x tending to 1 plus f of x is equal to limit of h tending to 0, 3a into 1 plus h plus b. H is tending to 0. So that will be, which means this is 3a plus b. From 1 and 2, you get, they are equal. 3a plus b is equal to 11. Mark that as equation number 3. 3a plus b is equal to 11. Now you take the left limit. Limit x tending to 1 minus f of x is equal to limit h tending to 0 minus f of 0 minus h. That is equal to 5a into 0 minus h. Sorry, 1 minus, no. So 1 minus h, 1 minus h minus 2b. H tending to 0. H tending to 0. That is 5a minus 2b. Mark that as equation number 4. From equation number 1 and 4, you get 5a minus 2b is equal to 11 because it is continuous. Mark that as equation number 5. 3a plus b is equal to 11, which is equation number 3. Solve 5 and 3. That is third equation into 2. 6a plus 2b is equal to 22. Mark that as equation number 6. 5 plus 6. 5a plus 6a, 11a. 2b and 2b cancel. 11 plus 22 is equal to 33. So a is equal to 33 by 11, which is equal to 3. Substitute in any one of the equations. Substitute in equation number 3. 3a plus b is equal to 11. 3 into 3 plus b is equal to 11. 9 plus b is equal to 11. B is equal to 2. Therefore, A is equal to 3, B is equal to 2. So, we have come to the end of this chapter. And next Friday, you will have a test paper on continuity. Revise all your sections and come prepared for the examination. Thank you.